Alright, can you guys hear me okay?
Uh, yeah.
Okay. Whenever I'm showing something on the screen, I'll try bringing the laptop closer to the screen so that I can show you what I have written there. Okay? So, what were we doing yesterday? Do you guys remember?
Yesterday we were doing star revision about what I needed help on, and then after that we were doing some geometry with shapes.
Okay. See what's up here? Uh-huh.
We had a big problem on the angles. We call this
Congruence. We were trying to prove that
congruent.
theorem for congruence. Okay? And I was pretty close to explaining that concept, but I kind of got little distracted when I was thinking a different direction, and that is how I was not able to get a conclusive view to what I was trying to explain to you guys. Okay, so in today's class also we'll focus on that congruence part. Okay, so first of all, whatever we learned, let's do a quick recap. Okay, when you talk about congruence of any shape means something that is an exact replica of it. Okay, if I say this hand and this hand are congruent, meaning I can simply overlay one over the other and it gives me a feeling of only one thing. You don't see two hands, you are seeing only one hand right now. If both my hands were not congruent, you would have seen something like this. Yeah? So congruence, anything that is congruent, or congruence is a property which says that two things are congruent if they are exact replica of each other. Now, geometry gives us different ways to prove that congruence. And here we will talk more with respect to triangles for now. Okay? How do you prove the congruence of two triangles? There are different ways of doing it. There are four theorems or axioms. Do you guys know the difference between theorem and axiom? No. Axiom is something which is proven. You don't have to prove it. If I say 20 plus 60 is equals to 80, you never have to prove that. That's more like an axiom. It's given. 20 plus 60 will always be 80. Okay. If I say every triangle has three sides, that's an axiom. You never have to prove that, okay, prove that a triangle has three sides. Nobody will ever ask you for that. Theorem is something which is a known fact, but you can also prove it. So that's the difference between the theorem and axioms. Okay. So for proving the congruence of triangles, there are four axioms plus theorems together. So one is called axiom, three are theorems. So let's look at that. SAS, ASA, SSS, RHS. These are four theorems and axioms. First one is the axiom. You don't have to prove it. Next three are called theorems. So I'm repeating that for you, Srivatsam, if you can see the screen. There are in total four theorems or axioms. Okay. One is SAS, that is an axiom. You will ask me what is S, what is A. So S stands for side, A stands for angle. So when I say SAS is an axiom, that means that is a proven fact which says two triangles are congruent if the two sides are same and the angle between them is the same. Now, if you look at the example of it, these are two triangles. If they are congruent, meaning they are exact replica of each other, based on this axiom, it says if the two sides are same and the angle between them is the same, meaning this side and this side are same, this side and this side are same, and the angle between them is matching. What that means is, if this is a situation, you can assume that these two triangles are exact replica of each other, meaning this side will be same as this side. This angle will be same as this angle. This angle will be same as this angle. This one you don't have to prove, okay? So let's not waste any time. Now, you might want to say why you have to believe me. I mean, very simple. Math is not to be believed, math is to be done. Now you should look at this. Imagine this is not a triangle yet. This is just an angle. These are two sides making this angle. These are two sides making this angle. Now, what you have done, you have taken two arms to make this angle. The length of the arm is fixed, the angle is fixed, the inclination is fixed. You're not reducing the angle, you're not increasing the angle. That means the distance between this point and this point will be fixed, it will not change. You're saying that this is my angle. My hands are glued in this position. So my distance between this finger and this fingertip is not going to change. It is glued, it is fixed. These two arms are fixed, length is fixed. Here to here, my hand's length is not increasing. So the distance will not change. So this side and this side will be the same. Okay?
Okay.
So that's why this is called axiom. Say, okay, if you are talking about two sides making this angle and this angle is fixed, the distance between them is not going to change. This side and this side will be the same because the angle is same, the arm length is same. Okay? That's why they say don't have to prove this. This is proven that your three sides are matching. Now another thing that will come into picture is called concept of similar triangles. Do you know what is similar triangle?
Yeah, I do.
Do you remember? When we were learning how to prove the Pythagorean theorem, that is when we touched upon the concepts of similar triangle. Similar triangle is nothing but, Srivatsa, you want to say that? What is similar triangle? Conceptually, I mean.
So basically, similar triangles are like basically triangles with the same angles
Yes.
measurement.
Yes. Similar triangles are triangles with similar measurement. Meaning, let's say this triangle and this triangle are similar triangles. Why? The angles are same measurement, sides may not be. So similar triangle tells you that if there are two triangles which are similar, meaning if this is 60 degree, this is 70 degree, this is 50 degree, this is 60 degree, 70 degree, and this is 50 degree. The angles are matching, sides are not. So this is like a squeezed version or expanded version of the same triangle. If you look at this is a base triangle, this is expanded version. You have zoomed in. Here, this is the same triangle. This is zoomed out version of the same triangle. You are moving away, seeing a smaller version of it. So what similar triangle tells is that if the two triangles are similar triangles, the sides will be in the same ratio. Meaning opposite sides. This is 50 degree, this is 50 degree. Meaning, let's say this is, let's give it a name, DEF. This is 50, this is 50. So the sides opposite to that, AB by, this is 50, so AB by DE will be same as next angle 70 and this is 70. Side opposite to that is AC divided by DF. And you can extend it further and say third angle is the same as 60 degree. Side opposite to that is this one, BC. BC divided by EF. This is a property of a similar triangle which says if there are two triangles which are similar triangles, their sides opposite to the matching angle will be in the same proportion. Okay?
I'm writing it down.
Yeah, sure. Srivatsa, are you with me?
Yeah.
Okay. So we'll use this concept also. Here you saw that with this SAS, that if the two sides and the angle between them are the same, these are called congruent. These triangles are congruent. and you don't have to prove it. This is an axiom. Because you see, you also, I mean, if you still want to double confirm it, you see that, okay, this side and this side will be the same. Because the distance between them is same, angle is same. If my angle reduces, then the side length reduces, right? This is not changing. So the sides are same. So all the three sides are matching. This angle is matching. Now, what will happen is, these are three sides which are all same. So the angles will be in the similar proportion actually. I mean, you can prove it the reverse actually. If the angles are same, then the same proportion. Here the sides are in the same proportion actually. So the angles will be the same. So basically here all the three angles are matching, the three sides are matching. That's why these are congruent. So the first axiom is simple. You don't have to prove it. We were just doing that extra check from our side. That is it valid? Yeah, the two sides are matching. Third side will anyways match because my angle is same. Is it disturbing? Can I close one of the doors? Yeah, okay. Just 1 second. Are you guys feeling cold?
I'm now.
So, yeah. So what I was saying was that the axiom you don't have to prove, but we are still doing an extra check from our side just to be doubly sure that this is true. Okay. Now, let's look at the three theorems: ASA, SSS, and RHS. Okay. And this is what we'll try proving. But remember one thing. Whatever we will do, we'll try relating with this guy because this is a proven fact. If we have to prove this, I will see if it is anywhere closer to this. And if you find it close to this is a proven fact. So that means this is proved. That's what we'll try doing. Okay? So let's look at the three theorems one by one. Here, among the three theorems, these two are for all types of triangles. ASA and SSS is for all types of triangles, wherein this one is for right angle triangle. So A stands for angle, S stands for side, A stands for angle. S stands for side, S stands for side, S stands for side. R stands for right angle triangle. In a right angle triangle, if the hypotenuse and one of the sides are matching, then the triangles are
Same.
congruent. Okay. So I'm just repeating myself. So basically the three theorems that we are looking at, ASA and SSS and RHS, these three we are trying to prove. First two are for any type of triangle. The third theorem, RHS, stands for, it is valid for only right angle triangle, which says that two triangles will be congruent, two right angle triangles will be congruent if H as in hypotenuse and one of the sides are matching. Okay? So let's look at the easiest one, RHS. Okay? I have one right angle triangle, another right angle triangle. What this guy is saying is, in two right angle triangles, if the hypotenuse are matching, so this and this are matching, and one of the side is matching, this side and this side are matching. Okay? Then these two triangles will be congruent. Now, these two are right angle triangles. Okay? So this is 90 degree and this is 90 degree. Yeah? Now, if the hypotenuse are matching, if one of the side is matching, do you think the other side will match or not? They will match, right? Because if let's say hypotenuse C and the sides are A and B, we know by the Pythagorean theorem for so here C is the hypotenuse, let's say B is one of the side. So if C and B are matching, A has to match between the triangles, correct? Srivatsam, are you with me?
Yeah.
So what is happening here is, as per the RHS rule, it's saying that if the hypotenuse and one side is matching in the right angle triangle, these two triangles will be congruent. I'm not believing that theorem. I'm wanting to prove it. So now by looking at this and this are matching, this are matching. That means this side is also matching. Now look at this. So this side and this side are matching. What is my axiom always that I'll be leaning on is SAS, because that's a proven fact. Meaning I will only believe this theory. Meaning if I have two sides and the angle between them matching, then it's a congruent triangle. This side is matching. This side is matching. And the angle between them is matching. Aligns with this SAS axiom. I don't have to prove it. Only thing we did was we made sure that the two sides which is making that angle between them are also matching. If they match, we can trust it. Yeah? So we did not trust this theorem. This theorem says that if you have two right angle triangles and the hypotenuse and one of the sides are matching, then the triangles will be congruent. I said, no, I don't trust you. Let me first look at the scenario. These two are matching. This side also matches. And as per the axiom SAS, side angle side, meaning the two sides making the angle between them. If the two sides are matching and the angle between them are matching, then there is nothing to prove. So this actually got proved by finding this area, this sides being same. Yeah, we can relate it with the SAS. Done. We don't have to prove it anymore. Clear, right? Srivatsam? You agree how the theorem IHS got proved?
Yeah.
Yeah. Okay. Now let's look at the next one. Let's look at RHS I am taking out of the situation. Now let's look at ASA. What this theorem says, that two triangles will be congruent if the two angles and the side between them are matching. Meaning, this triangle, this angle, this angle are matching. This angle and this angle are same. This angle and this angle are same. And the side between the angles, if they are matching, they will be congruent. Now, we will always try to find out SAS. Let's look at one practical situation, okay? Before we try proving this. These are my two arms, okay?
Yeah.
And look at the distance with my elbows, okay? I have kept my arms at a certain angle, both angles. If the distance between my elbows are the same and the inclination of both my arms are the same, this hand and this hand's length will not change. This can only change if I keep the angle same but I brought my elbows closer, meaning I reduce this side. The only way this arm's length will change is by bringing the elbows closer. If I am keeping my elbows at the same distance and I am not changing my angle, this arm length and this arm length is actually fixed. It cannot change. If I keep the angle same, meaning my inclination of my arm same, I move it far. That is when these two will become bigger actually, right? If I move them far, this is becoming bigger. If I move it closer, I am not changing the angle. Remember, this angle I am not changing. I am not putting my hand down. I am keeping it the same angle. I am bringing it closer or farther. Yeah. See, if I am bringing it closer, meaning I am reducing the distance between my elbows, that is when my arm becoming shorter. If I increase the distance between my elbows, my arms are becoming longer. Yeah. This is one practical example. Now, if you have to prove this mathematically, Okay? See what's up? Were you able to follow what circus I was doing here?
Yeah.
Okay, okay. So, Srivastava agreed that I was doing circus. Oh, okay, no, I was just. Now, let's say this side and this side is fixed. Okay? That is what this theorem says. This angle and this angle are same length. This angle and this angle are same length. Same angle. This angle and this angle are same in value. Now, if we can find that this side and this side are same, or this side and this side are same, then my SAS kicks in. So I have to just prove that this side and this side are same, or this side and this side are same. One of the two. So let's deal with this scenario. I have two triangles. This side is known to be same. This angle and this angle are known to be same. This angle and this angle are known to be same. Now, there are two scenarios that we're talking about. Let's pick up this one. A, B, C, D, E, F. Let's pick up this side. Okay? AB, there are two possibilities. AB is equal to DE. This is one possibility. Second is AB is not equal to DE. There is no third possibility, right? There are only two options. Yeah?
Mm-hmm.
See what's up? Are you with me?
Yeah.
There are only two options. If my first assumption or option is right, what's happening? AB equal to DE. So side, angle, side and matching. This is proved. No problem. This is the first scenario. You can, if you have to prove that, you'll say, okay, my first assumption is these two sides are same. So then SAS kicks in, done, proved. If my second option is right, meaning AB and DE are not same, okay?
Okay.
This and this are not same. That means maybe I have to draw a line like this, and let's say cut somewhere here on K, such that BK and DE are equal now. Okay? Yeah?
Yeah.
So here now BK and DE are equal. Okay? And this and this are equal. This side and this side are anyways equal.
Mm-hmm.
This angle and this angle are anyways equal. Yeah? So what's happening here is, look at this triangle and this triangle. This theory is not proving right. Because what's happening is, in these two triangles, right? This small triangle and the big triangle. Okay? I mean the extended one. This side I am saying is same as this side. If these two sides and this angle are matching, one second, let me rephrase it. If this and this are matching, am I getting stuck in the same place again? Yesterday I was doing this.
If you change where your B intercepts your angle measurements, they change.
Right. The angle measurement will change actually. Yeah?
They say you have to have two angles at the same
Right.
So
Correct. Yeah, correct. Now I get it. So I was getting stuck with the definition part of it both the times. So here now look at this one. So Srivastava, you are with me so far, right? You can hear me what I'm saying?
Yeah.
Okay, so now let's look at the second scenario when AB is not equal to DE. Okay? What's happening here is, see, like the example that we were giving here, right? That if my angles are the same, my base is same, by no means my hands can be of different length. It has to be the same length. But in this case, when I'm assuming that AB and DE are not equal, this and this are not equal, I'm actually forcing something which is practically not possible. I'm saying that this side is actually changing and this arm is remaining the same. So basically, like if you look at this one, this arm and this arm is fixed and the angle is fixed. This distance cannot change. Same way here, both the arms are fixed. The distance between the elbows is fixed. The angle is fixed. By no means this can vary actually. This has to remain fixed. So when we assume that AB and B are not equal, this assumption was itself wrong. That's why this BK being equal to DE is not a practical scenario. That's a hypothetical scenario. So here for proving this theorem, right, you have to, this theorem is always right, okay? We are just trying to prove that. And here we have to look at the two scenarios. One scenario is when these two sides are same, then that is proved using SAS. When the two sides are not same, we are contradicting ourselves by the basic principle of the triangle itself. So that when these are not same, this is not a correct scenario, and that is how this assumption is not right. So this is proven by the first assumption that my AB was equal to DE. So this and this was same. That assumption was right because my angles are matching. So the SAS kicks in. This side and this side are same, and my angle between the two sides are same. This side is anyways given the same. So this is correct. See what's up? Did I go very fast to confuse you? You got it?
Like sometimes my connection is not good, so I couldn't hear you.
Okay. No, so the way I will summarize this is when I am trying to prove the ASA one, right? I have two triangles where the two angles are same and the side between the two angles are same. What we are trying to do is we are trying to always relate that with the axiom SAS, meaning two sides and angle between them. If we find that combination to be right, then we can say that okay, based on that axiom, this is correct. Okay? Because this is a proven fact. Now in this scenario also, we are looking at the two triangles and we said okay, these two sides are anyway same, angles are same. Let's look at one pair of sides, this side and the angle. And we made two assumptions, say okay, there are two possibilities that can happen. The two sides are same, then SAS applies and we can prove it. Second assumption we made was if the sides are not same. If the sides are not same, then what happens? And then we looked at the property of the triangle or the alignment of the sides, saying okay fine, this assumption of these two sides not being same is not correct. So that is how we'll go with the first assumption, and that proves that this theorem is also correct. What this theorem says, that if there are two triangles where the two angles are same and the side between the two angles are same, those triangles are congruent. Meaning how you will use those theorems. Let's say you get two triangles to deal with. You get some sides value and some of the angles value. You have to find out whether those are congruent or not. So you will try relating that with SAS or ASA or SSS. Meaning if there are two triangles where all the sides are same. you'll say that using this theorem, you can assume that all the angles will also be the same because they are congruent. Yeah?
Yeah.
So let's look at SSS. ASA we looked at. Any confusion so far?
I don't think I'm confused.
Okay. No, I mean, I have to keep on asking, okay, because if I find anybody is confused and I'm just rushing through it, I'm not doing my job right. Okay, that's why I have to keep on asking. It's not to make you guys feel that you have not understood. It is just to make sure that I have explained it well. Okay.
Okay.
Now the next theorem is SSS. It stands for side, side, side. Okay. How you can write this theorem or describe this theorem is, there are two triangles, they are supposed to be congruent or exact replica of each other if the three sides are matching with each other. Meaning, if I have two triangles where side A is matching with side A, side B is matching with side B, and side C is matching with side C. They are congruent. That's what this theorem says. Now, I will not try proving this because this is pretty much in line with the basic principle of similar triangles. Like I was saying, that if there are two triangles which are similar, meaning the angles are matching, then the ratio between the sides AB by DE equal to BC by EF equal to AC by DF. Okay? So, similar triangle says that if the two triangles have same angles or matching angles, their sides will be in the same proportion. Here, this theorem says the sides are in the same proportion actually. They are matching. Side A by side B. This side and this side are same. So side A by side B equals to 1. This side and this side is same. Side B by side C equal to 1. This side and this side is same. So side C by side C equal to 1. So they are in same proportion already. If they are in same proportion, that means they are similar triangles. Meaning these angles also are matching. If the angles are matching, now you pick up any combination of SAS. This side anyway is matching. You pick up this angle. This angle is also matching because you got the proportion right. This side and this side anyway is matching. These two are same. So you pick up any combination of two sides and angle between them, and that is right. So that aligns with the axiom. So this is congruent. Okay? See what's up? Are you with me? Yeah. So now, good thing for you guys is you don't have to really memorize how to prove it. I was proving it just because I wanted you guys to be well versed with these theorems or axioms. More like property of triangles basically. If you're dealing with triangles, see, nobody will say, okay, I don't think here in the US, I have heard it when I was teaching my elder daughter for SAT preparation, right? I never heard her talking about the theorems or axioms, okay? I never heard her talk about SAS, ASA, SSS or RHS. This is something that I had learned when I was a child. When I was teaching the kids here in India, I walked them through these theorems. So that is why I thought, maybe I'll explain that to you guys. How this will help you is when you are dealing with any math, any word problem or any, let's say somebody says, okay, fine. These are two triangles. Find out this side and this side are same. This side and this side are same. Okay, this angle is, let's say, 40 degree and this is also 40 degree. Find out the length of this side, these two sides, and and corresponding angle. What you will do is you will apply, say, fine, okay, these two are congruent triangles. Then, if you know one side, what is the corresponding side? You just get that value. You don't have to do a hell lot of calculation to find it out. Yeah. So we'll apply these formulas to find out triangles which are congruent. These theorems basically to find out the theorem triangles which are congruent and the relationship among those properties, and then use that information for doing further calculation. That's all. Okay. See what's up? Are you with me? Okay. Now, so this is on the congruence of triangles. What else do we want to learn today? Before we say that the week is over. Huh? Functions.
What about algebra 1? Cause for me at my school district, if you're in advanced math next year, we could learn about algebra 1.
Okay. So algebra 1, we'll start picking up algebra 1 also, and we'll pick up topic by topic. Okay. Because I keep hearing this algebra 1, algebra 2 from different kids, but for me, every concept is part of algebra 1 or algebra 2. Okay. So we'll pick up topics by topic. Okay. So in algebra 1, when you come in the next class, you tell me these are the 2 topics that I want to learn, and then we'll go from there. Okay. So we'll pick up topic or the concepts. We'll try learning that, because I would not remember what is in algebra 1, what is in algebra 2. I would know the concept part of it. Okay. That's how we'll plan. So look at the topics. Give me a list of all the topics that is there in algebra 1, and we'll cover that one by one.
Okay.
Okay?
Okay.
Yeah. Okay. You were saying functions. Okay.
Are functions a part of algebra 1?
I would not know. I'll check.
Okay.
I mean, it's difficult to memorize. I myself don't put much effort for memorizing maths. I always lean on concepts. So that's why.
What time is it?
What time is it? It is 5:42.
5:42.
Okay. Yeah.
Oh, so I have to go to another class soon.
Okay.
Okay. It starts at 6:10. And it like takes like, and it's like far away from here.
Okay.
So can I leave?
Yes, sure. You can. So you can watch the video of the class weekend for knowing what the functions. Okay. Okay. So we'll spend 15 minutes to quickly run through some of the concepts of function, and then remaining things we'll learn in the next class. Now, let's say I just wrote this on the table, on the screen. X squared plus 5x. Okay? So this is called a function with 2 terms. This is one term, this is second term. If you write this equal to 5, this becomes the equation. Here I am writing this without the equal to sign as a function of x. Okay? Here I have only one variable. So this is a function with one variable but 2 terms. If I write an equation like x squared plus 2xy plus 7y, this is a function with 2 variables with 3 terms. So between the operations, right? If you take out the operands, how many separate things you are dealing with? How many operations? So this is called one term. This is called one term. This is called one term. So here we are talking about 3 terms. So function is nothing but a way to represent a variable with certain number of terms without an equal to sign. It just shows a relationship. So if I'm talking about, I mean, at this level probably till I would say 10th grade or 11th grade, like till SAT, you will not deal with function with multiple variables. We will deal with function with one variable with multiple terms. So if you are looking at x squared plus 6x plus 9, here we are talking about a function with 3 terms, and here there is only one variable x, and there are different powers of x. Here you have power of 2, this is power of 1, and here you can say x to the power of 0 also. So there is only one variable. Or there is another way you can put this. So this is not function, this is called expression. I was wrong actually. This is called expression. And if you represent that as an expression with variable x, you can write this as a function. This is when it becomes a function, where you are saying that this expression is explained as a function of x. This is an example. Okay. What we will do is we will deal with different types of functions with multiple variables and the exponents. These are three things.
Excuse me?
Yeah.
I was wondering if you like to participate in a football fundraiser.
Not really. I'm in the middle of a class. Sorry. Okay. So function is nothing but a mechanism to represent an expression in terms of a variable. So you have variables, you have constants, you have exponents, and you have terms. These are 4 things that you always deal with when it comes to function. So the way you will read this is function of x with 3 terms with exponent or power of 2. This is the basic definition of function. We will deal with more of example, we'll do more sums. Any questions that you have, any particular question that you want to get started with, I can do that.
More like with sloping it.
Yes, so we'll come to that. So right now we are dealing with a function with variables, exponents. There are different types of functions. You deal with linear functions, you deal with quadratic functions, and that translates into different equations or the slope. So if you're dealing with a linear function, you are essentially talking about something with the exponent as 1, the maximum power is 1. So you can say fx equals to 2x plus 7. Or you can always say that y is a function of x, where y equals to 2x plus 7. This is a linear equation. When you draw this on a graph paper, this draws a straight line for you. If you are talking about a function of x, which is, let's say, 3x squared plus 7x minus 9. Here you see the exponent is 2. So this is not a linear function. This is a quadratic function. And then this, when you plot this as y as a function of x on a graph paper, you will see that this makes a curve, a parabola. Yeah. So right now, Srivatsava, we have just looked at the basic constructs of what is a function. Okay. Because Pranit wanted to talk about what is function, what is the relevance of function. So we just looked at what are the key constructs of a function, where we looked at any function can have n number of terms, which is separated by the operations, and then the power of the variable, which is also called the exponent, that derives what kind of function we are dealing with. Are we talking about a linear function, which eventually draws a straight line for us when you plot that on a graph paper, or it draws a parabola if you look at a quadratic function. Okay. So function equations, these are very interchangeably used. Only difference being function is a representation of the relationship of a variable without equal to sign. When you put an equal to sign, that function becomes an equation basically. Yeah?
Yeah, unknown functions.
Yeah. So basically, now one thing for you guys is, since three of you are in senior grades, what I would do is, so far we were going in a very, what do you call, random way. We were focusing more on star. Now what I will do is, I'll go back to the old pattern where I have a list of all the topics listed for level 2, and make sure that we have covered all of them, or at least you guys are known, I mean, those topics are known to you, the concepts are clear to you. If there is something that is not clear, let's spend next 1.5 months to clear all those concepts, so that before you guys start your next grade, I'll move 3 of you into level 3. Okay, level 3 is where we will learn more of algebra 1, algebra 2, or the other concepts that we have to prepare for with respect to SAT, so that you guys have enough time. My goal is to make sure that you guys give your first SAT by the time you are in the first trimester of grade 10. So that way you would know how far or close you are from getting a perfect score in your maths part. Okay, and then if you can get a very good score in the first trimester of 10th grade, rest 2 years you can literally have fun. Yeah. So, Srivatsava, you are in 8th grade. Pranit, you are also in 8th grade. I think Mitran is in 7th grade, but he is doing advanced algebra. So let him be part of the same class. If he is catching up well, wonderful. If not, he will continue for some more time. Yeah. All right. That brings us to the end of the class. Any questions before we wrap up? Srivatsava? No? Okay. So one more thing that we'll start doing gradually is, do you guys use Khan Academy? Yeah. So once we start the level 3, what we'll do is we'll start doing more of practice of the unit test in Khan Academy itself. So that way you'll get acquainted with the questions that gets asked in the SAT and all, and you'll be dealing with the practical questions that everybody prepares for. At least you would know how close or far you are with respect to the kind of questions that you'll be dealing with. Yeah. All right. So, but that is after summer break. Okay. So, for next 1.5 2 months, we'll make sure that we cover all the concepts that is there for level 2, meaning up to 8th grade, so that when we go to the level 3, there is nothing that is there as a backlog for us. Okay? Yeah? Alright then, enjoy the rest of your evening. We are pretty much done with the weekend, and I'm starting my new job from tomorrow. So that's going to be a different experience. Let's see how it goes.
Good luck.
Thank you. Bye-bye.